NASA's Voyager 1 spacecraft, the most distant human-made object ever created, has achieved an extraordinary feat by venturing into the uncharted territory of interstellar space. Launched 45 years ago in the summer of 1977, this remarkable spacecraft continues to explore regions of the cosmos it was never intended to reach, far surpassing its originally planned mission lifespan. Designed for a modest 4-year journey to study the outer planets, Voyager 1 has defied expectations, becoming a testament to NASA's ingenuity and the enduring spirit of human exploration. Despite relying on technology that predates even cassette players, hardware that seems almost archaic by today's standards, it continues to transmit valuable data back to Earth, offering scientists a window into the farthest reaches of space. Recently, Voyager 1 made a discovery so profound that it has shaken the scientific community, captivating the world with its implications and reminding us of the boundless possibilities that lie beyond our planet. The story of the Voyager missions began with a pivotal moment in the history of space exploration when two of the most ambitious projects ever conceived by NASA took shape. In the 1960s, Gary Flandreau, a visionary scientist at NASA's Jet Propulsion Laboratory, laid the groundwork for what would become an unprecedented journey. Armed with nothing more than a pencil, paper, and his extensive knowledge of celestial mechanics, Flandreau meticulously mapped out an optimal route for spacecraft to visit the distant planets of Jupiter, Saturn, Uranus, and Neptune. His calculations revealed rare and fortuitous celestial alignment occurring in the late 1970s and early 1980s, a configuration that happens only once every 176 years. This alignment would allow spacecraft to harness the gravitational forces of these massive planets, effectively slingshotting from one to the next in a cosmic game of pinball. By leveraging this phenomenon, known as a gravity assist, the journey time from Earth to Neptune could be slashed from an arduous 30 years to a mere 12, making the mission not only feasible but revolutionary. Recognizing the once-in-a-lifetime opportunity, NASA moved swiftly to capitalize on Flandreau's discovery. In the summer of 1977, the agency launched two identical spacecraft, Voyager 1 and Voyager 2, just 15 days apart, embarking on what was initially planned as a 4-year mission to explore the outer planets. Little did anyone anticipate that this mission would evolve into an enduring odyssey, one that would stretch across decades and redefine humanity's understanding of the cosmos. Both Voyager's spacecraft remain operational more than 45 years later, continuing to send back daily streams of data from the fringes of our solar system, traveling far beyond what was initially imagined. Voyager 1 and Voyager 2 have earned their place as the most distant human-made objects in existence, shattering all previous records in the annals of space exploration. The discoveries made by the Voyager spacecraft have fundamentally transformed our understanding of the outer planets and the distant regions of the solar system. In their early years, the twin probes provided humanity with breathtaking close-up images and groundbreaking scientific data about the moons of Jupiter and Saturn. The revelations unveiled a dynamic and active world far beyond what scientists had ever anticipated. For instance, the discovery of active volcanoes on Jupiter's moon Io stunned researchers, who had previously assumed that such small celestial bodies would be geologically inert. Similarly, vast ice fields and complex surface features on Saturn's moons challenged long-held assumptions about the geological activity of these distant worlds. Voyager 2, in particular, achieved historic milestones by becoming the first and so far only spacecraft to visit Uranus in 1986 and Neptune in 1989. These flybys offered humanity its first detailed glimpses of these enigmatic ice giants, revealing astonishing details about their atmospheres, magnetic fields, and moons, and forever altering our perception of the outer solar system. As of today, Voyager 1 and Voyager 2 are over 14 billion km from Earth, a distance so vast it defies comprehension. The spacecraft, each roughly the size of a Volkswagen Beetle, continue to push the boundaries of human knowledge despite being equipped with technology that would seem primitive by modern standards. With just 69 kilobits of memory, less than the capacity of a basic smartphone, they rely on their onboard intelligence to navigate the complexities of deep space. The instruments collect a wealth of data, which is stored on 8-track tape recorders, a relic of 1970s technology, before being transmitted to Earth. Remarkably, the spacecraft communicate using only 23W transmitters, equivalent to the power of a household light bulb. Yet, through the use of NASA's 12M satellite dishes, they have maintained contact with Earth, sending signals that take over 18 hours to travel the immense distance. This feat of engineering underscores the brilliance of the Voyager design and the dedication of the teams that continue to monitor their progress. The journeys of Voyager 1 and Voyager 2 have been fraught with challenges, each overcome through a combination of innovative engineering and sheer perseverance. After departing Earth, the spacecraft had to navigate the treacherous asteroid belt, a region filled with rocky debris that posed a significant risk to their delicate instruments. Only a handful of spacecraft had successfully traversed this hazardous zone before them, making their safe passage a notable achievement. As they ventured farther from Earth, the growing distance introduced new communication hurdles. The faint signals from the spacecraft had to compete with the ever-increasing background noise of modern technology, including radios, televisions, and cell phones. Despite these obstacles, the Voyager probes have continued to astonish astronomers with their unexpected discoveries, revealing the wonders of the vast interstellar void and deepening our appreciation for the complexity of the universe. One of the most profound aspects of the voyage emissions has been their exploration of the heliosphere, the immense bubble of solar wind and magnetic fields that envelopes our solar system. Beyond the heliosphere lies the enigmatic or cloud, a distant region populated by comet-like objects bound together by the sun's gravity and stretching toward the nearest stars. The Voyager spacecraft are gradually approaching this mysterious realm, but their entry into interstellar space began when they cross the helop, the boundary where the solar wind gives way to the interstellar medium, initially estimated to be about 50 astronomical units from Earth. Astronomical unit being the distance between Earth and the Sun. This crossing marked a historic milestone in space exploration as Voyager 1 became the first human-made object to venture beyond the influence of our Sun. The transition into interstellar space, however, did not unfold as scientists had predicted. Researchers had expected the spacecraft to encounter a sudden surge in cosmic rays, high-energy particles traveling at nearly the speed of light as they exited the heliosphere. Instead, Voyager's data painted a more nuanced picture. Most of these high-energy particles were deflected by the heliosphere's magnetic shield, which acts as a protective barrier against many external cosmic threats. Similarly, scientists had anticipated a significant shift in the magnetic field's orientation as the spacecraft moved from a region dominated by the Sun's influence to one, shaped by the broader interstellar environment. Yet, Voyager's instruments detected no immediate change in the magnetic field, leaving researchers puzzled and prompting a reevaluation of existing theories about the nature of this boundary. On August 25, 2012, Voyager 1 officially crossed the helipause, becoming the first spacecraft to enter interstellar space. Probe transmitted data confirming an increase in plasma density, one of the key indicators of the interstellar medium, but the absence of the expected changes in the magnetic field challenged conventional models. This unexpected finding forced scientists to rethink their assumptions about the boundary between our solar system and the cosmos beyond. The Voyager missions have thus redefined our understanding of the heliosphere, offering fresh insights into its structure and dynamics. The discoveries underscore the value of exploration, as even the most carefully crafted hypotheses can be appended by the realities of the universe. The Voyager spacecraft continue their solitary journeys. They provide invaluable data about the interstellar medium, a region composed of ionized gases and shaped by the influence of nearby stars. Once thought to be a near empty void, this environment has proven to be a complex and dynamic space with profound implications for our understanding of the cosmos. The Voyager probe's findings have not only expanded our knowledge of the universe, but also highlighted the ingenuity and foresight of the scientists and engineers who designed these extraordinary machines. Their ability to function in such extreme conditions, far from the warmth and light of the sun, is a testament to the brilliance of their creators and the resilience of human ambition. The Voyager missions stand as a powerful symbol of humanity's enduring quest for exploration and discovery. They have opened a window into the vastness of space, revealing worlds and phenomena that were once beyond the realm of imagination. As they drift ever farther from Earth, the Voyager spacecraft serve as a poignant reminder of our place in the cosmos, inspiring future generations to reach for the stars. Their legacy will endure as a beacon of what is possible when curiosity, ingenuity, and determination converge to explore the unknown. More than mere technological marvels, the Voyager spacecraft embody humanity's profound desire to learn, explore, and transcend boundaries. Launched over 4 decades ago, these twin explorers have reshaped our understanding of the universe and ignited countless dreams of what lies beyond. Even as they venture deeper into the abyss, their legacy continues to grow, serving as a testament to the power of scientific curiosity and perseverance. One of the most inspiring aspects of their mission is their ability to keep functioning despite the immense challenges of their journey. Operating at distances where sunlight is little more than a faint glimmer, the spacecraft rely on nuclear power generators fueled by radioactive plutonium. This power source, the gradually diminishing, has allowed them to defy the constraints of time and technology, enabling them to transmit data long after their original mission was expected to end. Over the years, NASA has meticulously managed the spacecraft's power usage, shutting down non-essential instruments to conserve energy and extend their operational lives. This delicate balancing act has stretched the mission far beyond its initial scope, providing humanity with a treasure trove of data about the cosmos. The fact that these aging probes continue to communicate with Earth is nothing short of miraculous. Tribute to the foresight of their designers and the dedication of the teams that monitor their faint signals. A particularly remarkable feature of the Voyager spacecraft is the inclusion of the Golden records, photograph records that carry sounds and images representing the diversity of life and culture on Earth. These records are humanity's message to the stars, a symbolic gesture of our existence and our longing to connect with any intelligent life that might one day encounter them. The records contain greetings in 55 languages, music from cultures around the world, and natural sounds like waves, thunder, and bird song, encased in gold-plated covers with instructions for their use. The golden records are a testament to humanity's hope, curiosity, and aspiration to be part of something greater than ourselves. As the Voyagers drift through the cosmos, they carry this message of unity, a reminder that even in the vastness of space, we seek to share our story. In conclusion, the Voyager missions represent one of humanity's greatest achievements, blending science, engineering, and imagination to explore the unknown. Their discoveries have reshaped our understanding of the solar system and beyond, while their resilience continues to inspire awe as they journey farther into the interstellar void. Voyager 1 and Voyager 2 remain ambassadors of Earth, carrying our hopes and dreams into the infinite expanse of the universe.